Bismillah ar-Rahman ar-Rahim. Okay, this is Ziad Wahba, and today we will discuss some problems in the course of communication systems. The first problem we have here is mentioning the following: for a DSB-SC system with a channel noise PSD of Sn of f equal 10 power negative 12. This is the channel noise, okay, and we have a baseband signal of bandwidth 5 kilohertz. The receiver output SNR is required to be at least 47 decibel. This is like a design problem. This is the required value for the SNR. The receiver is as shown in figure 8.30, and this is the shape of the receiver. We are having here the SI and NI, which are the inputs, and this is 0 and N0, or S node and N node, and they are the outputs. So we will follow these following rule or formula. It's formula 8.111 in the textbook to solve the required ports. First of all, he's mentioning what must be the signal power SI received as the receiver input. So if we see here the formula, it mentions that S node over N node equal SI over MP, and this equal gamma. Gamma here is the value of the SNR. So if we wrote this problem here, SI, and this is the required one to be calculated in the first part, it over MP. This will equal what? The SNR. So first of all, we have the SNR here. It equals 47 decibel. The SNR equal 47 decibel, and the NP are the values of what? N is the value of the noise, which is equal to 10 power negative 12, and P is the bandwidth of the signal, which is 5 kilohertz. So N is, as we have just mentioned, 10 power negative 12. And B is what? B is 5 kilohertz, which is 5 times 10 power 3 hertz. Okay, so what are we calculating right now? N multiplied by P. If we multiply these two terms, we will obtain what? N node. And N node here is what? It is the receiver output noise power here, denoted by N node. Okay, so we have just calculated letter P. So by multiplying N by P, it will equal 5 times, by multiplying these two values, 5 times 10 power negative 9 watt. Okay, this is the measuring unit of the power, and we can just write it as this form, 5 nanowatt, by replacing the 10 power negative 9 by nan, and this is a valid thing. Then we will move to the part A. We will continue in this part, which is what is the signal power SI received as the receiver input. So to calculate SI, we will have to do what? We will have to multiply MP times SNR. So MP we have just calculated it to be 5 nanowatts, while the SNR it's calculated by using the following. It's equal 10. Well, we can say that, or one can say that it's already given. It's 47 decibel. However, I am dealing here with what? And I'm not dealing here with decibel. So I want to convert it from decibel to be a constant or a value with no measuring unit, so that I don't affect the measuring unit of the watt. So in order to convert the decibel to a constant value, all we do is the following. We replace the 47 by 10 multiplied by log function to the base of 10 of what? Of this value, of the 47 value. This is like a formula. This is a formula to convert the values from decibel to what? To a constant value. So by multiplying 5 nanowatt by 10 log to the base 10 of 47, we will obtain the following. We will obtain 83.60489 nano watt. And this is what? This is the measuring unit, or this is the power of the signal power SI received as a receiver input. This is the SI. So we have calculated part B at the start, which is N multiplied by P, and this is part A. Moving to part C, what is the minimum transmitted power S of T if the channel transfer function is HC of F equal 10.-3 over the transmission band. So I'm having here another formula saying what? The S of T equals S of I over H of C. So S of I have just calculated it. I just can take it as a copy here and divide by H of C, which is 10.-3. It is given in the problem. So by dividing these two values, I can write here this value and just remove the nano, put instead of it 10.-9 to make my life a little bit easier. And here divide by 10.-3. So what am I gonna get is the same value here. However, the only difference is the power of the 10, which will be 10.-6. Why is that? Because 10.-9 divided by 10.-3 equals 10.-6. And this is what? This is in watt, and I can replace the 10.-6 by micro watt. This is like the prefixes and suffixes and so on. And this is the solution of the first problem. I hope it's a little bit clear. It would be beneficial to know what is these symbols. As we have just said, SI is the signal input, the receiver input. NO is the receiver output noise power. ST is the minimum transmitted power. HC of F is a channel transfer function. And about it would also be beneficial to know what is the M, what is the N, what is the P. And here is a channel noise. In our example, P is the bandwidth,